Vamos a dar paso a nuestra primera conferencia del día titulada Nuevas estimaciones demográficas, a cargo de Stein Emil Vollset, profesor del Departamento de Ciencias Métricas de la Salud de la Universidad de Washington. Él cuenta con doctorado de la Universidad de California y lidera el equipo de escenarios prospectivos de salud. Les recuerdo que esta conferencia tiene el idioma original en inglés y deben activar el botón de traducción si la llegan a necesitar. Quiero darle una bienvenida al señor profesor Vollset. La audiencia es toda suya. Welcome, Mr. Vollset.
Good morning, everyone. I'm very happy to be here and present our new population forecast from the Institute for Health Metrics and Evaluation at the University of Washington. I will focus on the main results of our work with regards to population, but since population forecasting require forecasts of mortality, migration, and also fertility, which is the main driver of future population size, I will focus on aspects of these that are important to understand the differences between our forecasts and those of other major producers of population forecasts, for example, the United Nations Population Division. I think in this year, due to COVID, I think it's more clear to everyone that it's very hard to predict the future, and epidemics makes it even harder, although COVID is unlikely to affect long-term future population size. I will just begin with underlining the differences between our population modeling and that of standard demographic forecasts. We use the Global Burden of Disease Studies large covariate database to provide drivers in our models. As drivers of fertility, we have chosen to use met need for modern contraceptives and female education. Drivers of mortality is the IHME socio-demographic index, which is a composite of GDP, of mean educational level in the country, and total fertility below 25 years. In addition to that, we have around 70 risk factors in the GBD, for example, smoking, diet, body mass index, blood pressure, air pollution, lack of sanitation, lack of clean water or hand washing facilities, vaccine, and other drivers of specific diseases. And we use the link between these risks and cause-specific mortality. So, for example, we exploit the link between future smoking habits and lung cancer risk, or risks or diet risks and future cardiovascular mortality, and add all the cause-specific forecasts to the all-cause mortality in the future. We also have drivers for migration, social demographic index, the difference between birth and death rates, and deaths from conflict and natural disasters. So we have past time series for all these drivers, and we also need to forecast these drivers to 2100 for the 195 countries that are included in our study. For the population forecasts, we consider 5 different scenarios, and we have focused on the drivers of fertility, which is the major driver of differences between us and others when it comes to population estimates in 2100. We have the reference scenario, where we have all drivers at the most plausible level for in the future trajectories. Then we have a slower pace in growth of met need for contraception and female education at the 15th percentile of rates of change across past year and countries. and we have a faster pace of increase in met need to contraception and increase in mean educational level for women at the 85th and also 99th percentile of past rates of change across years and countries. And then we have the sustainable development goal pace with 100% met need for contraceptives and secondary education for all by 2030, which is the most optimistic in that sense future scenario. This is the paper we published in July, Fertility, Mortality and Migration and Population Scenarios for 195 countries from 1917 to 2100 from the Global Burden of Disease study. As we often do, we also released at the same time a visualization tool that is available from our website, healthdata.org, where you can visualize population size by age, by sex for all the 195 countries back to 1950 and all the way to 2100. You can also see for countries or aggregates of countries or global level total fertility rates, and you can also visualize population pyramids using that tool. There was a lot of attention when we attracted in the media by our paper. So a large number, hundreds of newspapers and news outlets around the world wrote about our paper, and we are very happy that the results attracted that much attention, and we hope that will incite a fruitful debate about the issues that the study results of our projection and also those of the United Nations and Wittgenstein Center that also produce population forecasts. The big picture results are as follows. In 1950, the world population was 2.6 billion people. Today, it's close to 8 billion. And according to our reference forecast, the world population will increase by 2 billion in the next 40, 50 years and peak in the mid-2060s at 9.7 billion. And then decrease by 1 billion in the last third of the century to 8.8 billion in 2100. And the 1 billion increase between now and 2100 that we see at the global level can be decomposed into an increase of 2 billion in sub-Saharan Africa. The sub-Saharan Africa population will increase from 1 to 3 billion according to our forecast, whereas we will see a decrease of 1 billion in Asia between now and 2100 from 4 to 3 billion. The next slide shows a graphical representation of these changes, where you see the dramatic growth in sub-Saharan Africa from 1 to 3 billion in red at the bottom of the graph. Then there is also increase in North Africa and parts of the Middle East, and that region will reach 1 billion in 2100. We can see then South Asia in green and Southeast, East Asia and Oceania in orange, where we see a population decline towards 2100. And then Latin America, Caribbean, Central East and Eastern Europe and Central Asia, there is a slight decline at this big picture level, and also for high income countries the population is relatively stable, but with declines towards the end of the century for all regions actually, except sub-Saharan Africa and parts of North Africa and Middle East. Since most of the changes we see is driven by fertility and fertility forecasts, I will go into a bit more detail about that and how the fertility levels is distributed across countries. To 2.1 children per woman is the fertility rate that is needed to maintain population in the long run in the absence of, for example, immigration. And this level around 2.1 it's a rough rule of thumb. It's called the replacement level, the fertility replacement level, and the validity of this rule depends on migration and other factors as level of mortality, age structure, and sex ratio at birth. But and other aspects with fertility forecasting and prediction is that it is very challenging to predict, and I will explain a bit why. But first, I will mention two important method improvements with our approach to fertility forecasting. Instead of modeling total fertility rate, which is a period measure, we have modeled completed cohort fertility at age 50, which represents a life course experience of women. And in this graph, we see that the completed cohort fertility, here shown from the 1970 to until current, is a more stable measure than the total fertility rate that tends to vary more because it is affected, for example, by postponement of births, which we are seeing in many countries, that women choose to have children at older ages when she has completed education or spent time in the workforce. So, but in addition to modeling completed cohort fertility, we model it with covariates. We model it as a function of female education, mean years of education, and contraceptive mat need. And that model, which is a global model in our approach, explains around 80% of the variability in the past completed cohort fertility in the past 50 years or so. And the expected number of children for a woman throughout her reproductive career is, if she has 16 years of education and 95% access to contraception, is 1.4 children per woman in the model we have used. Here I show to the left, United Nations Population Division. In the middle, the Wittgenstein Center in Austria, which also produces this type of estimates, and our estimates, IHME, on the right-hand side. The trajectory of total fertility rate from 1950 through the present, shown with the green vertical line, until 2100. And the gray lines are individual countries, whereas the red line is the global total fertility rate from 1950 to 2100. And we see the dramatic decreases we have seen in the past in total fertility rate, both globally, from levels around 5 to now hardly above the replacement level, and then the continued decline that we see in all approaches to fertility modeling. But there is one noteworthy difference between the United Nations fertility forecast, the Wittgenstein centers, and ours. And you can see that if you focus on in the lower part of the three graphs, below a total fertility level of 2.1, what happens in the future when a country reaches a fertility sub-replacement fertility somewhere between 1 and 2, then you can see that both the Wittgenstein and the United Nations estimates, they have what the demographer calls, we see what the demographer calls recovery, that there is, after reaching a low level, there is a tendency for many countries to recover. That is, that the forecasts tend to increase towards replacement level again. Whereas on the right-hand side, you see that in our model, once a country reach a low level of total fertility rate between 1 and 2, the country tends to stay at that low level throughout the century until 2100. So this is a key graph and the key difference, actually explaining most of the differences we see in the population forecasts. This graph shows total fertility for the largest countries in the world, either now or in 2100. I will not go into too much detail in this graph, only emphasize that the substantial decline we have seen in the past and the continued decline we see in the future, and the flattening towards the end of the century in most countries shown here, and also the relatively wide variation between the scenarios except in China. But all countries have relatively large uncertainty limits on the reference scenario, which is shown blue shaded. This is a big picture result of two important fertility parameters, or one fertility parameter, and then the consequence of that. And that is, in 1950, it's just a few countries that had total fertility below replacement, below 2.1, and very few countries, I think only 3 countries, had experienced a population decline from 1950 to 1951, or the first years of the 50s. In 2020, close to 100 countries are now more than half of the countries are below replacement, and close to 30 countries have already declining populations in 2020. When we jump to 2100, we see that the vast majority of countries will be below replacement, and almost all of those will have declining population size according to our forecasts, 170 actually. And we will have a look at where this is happening. This is 1950. Here we see all the 195 countries on the axis, and they are ordered by the global burden of disease, so-called super regions. To the left, in black, are high-income countries. The x-axis is the total fertility rate, going up to 8 children per woman. And we see that the high-income countries had the lowest fertility levels, most of them between 2 and 4, but very few in 1950 below replacement. And there were 2 high-income countries with declining populations, and that shown in yellow. And that was actually Ireland and Malta. In Central and Eastern Europe and Central Asia, that was shown in brown. Only 1 country was below replacement, and no countries had declining populations. North Africa and Middle East, most of the countries had fertility rates between 6 and 8, and also above 8. South Asia, fertility around 5 to 7. Southeast Asia, and East Asia and Oceania had fertility levels between 4 and 7. Latin America and Caribbean, most between 4 and 7. A few countries below 4. And sub-Saharan Africa, almost all countries between a fertility rate of 5 to 8. And you see only one country outside the high-income countries with declining population in 1950. If we jump to 2020, the picture is changed quite dramatically towards lower fertility levels. We see now the TFR on the x-axis is still from 0 to 7, about the same range, but almost all high-income countries are now below replacement. Also, all countries in Central and Eastern Europe are below replacement. Central Asia is most countries is above, and in North Africa and Middle East the picture is mixed, with some countries below replacement, some above. In South Asia, India is below replacement, only Pakistan is above, shown in green. In Southeast Asia, East Asia and Oceania, it's also mixed, with some countries below replacement. For example, China, which is the large country in this region, and in Latin America and Caribbean, most countries are either below or just above replacement. And we also see that now the number of countries in sub-Saharan Africa, all countries are above replacement, above 2.1. We also see that we have some high-income countries with declining populations, for example, Greece, Japan, Portugal and Spain, and many countries in Central and Eastern Europe are already observing population decline, and some countries in Latin America and Caribbean. If we jump to 2100, now we see that we have the vast majority of countries are below replacement. The only exception is in high-income countries is Israel, which is just above. A few countries in Central Asia, a few countries in Oceania, and a few countries in sub-Saharan Africa. And we also see that most countries, and the number is actually 170 of 195, the population is declining, shown in yellow. Now a jump from fertility to the other driver of population in the future, which is mortality. But mortality is a more stable measure, and there is also less variation between the different producers of population forecasts. So this is a less critical variable. What we see here is life expectancy for males on the left-hand side and females on the right-hand side. And we see that for the scenarios which is constituted of different rates of change in the future of contraceptive and education, those variables do not mean that much for mortality. So the scenario estimates are the differences across scenario estimates is relatively small. An important feature, though, is that although we will still see an increase in life expectancy globally until 2100, we see that the increase in life expectancy, according to our model, is decreasing. It's slowing down. We forecast less increase in life expectancy, both for men and women, in the next 50 to 80 years than we have seen in the past 50 to 80 years. This is global total fertility shown from 1990 to 2100. We see that today the mean number of children per woman is 2.4, and we expect that in our reference or most plausible scenario to go down to 1.66 with the uncertainty from 1.3 to actually up to replacement level. We also see that the more growth in access to contraceptives and female education lowers the fertility rate slightly, but not dramatically. But we see for the scenario with slower growth in female education and met need for contraceptives has a quite high total fertility in 2100 at 2.6, which actually is higher than the current total fertility rate. Here I'm showing our global population forecasts. In 2017, global population was 7.6 billion. We forecast in our reference scenario that the global population will increase to 9.7 billion in 2064 and then decrease about 1 billion to 8.8 billion in 2100. Here we see that the numbers according to the different scenarios, which means it's different future trajectories of education for women and met need for contraceptives, is quite wide, from 6.3 billion in the sustainable development goal pace of growth in contraceptive met need and education, and up to 13.6 if we have slow growth or in met need and female education. This is population size in the largest countries. 20 in the 10 largest countries, either in 2017 or 2100. In the upper left panel is China, where we see that population will peak in the 2020s and then decline dramatically by almost 50% to 2100. India's population will increase until around 2050 and then decrease to 21% of the current level in the reference scenario. Nigeria will become, according to our forecast, the second largest country in the world with a 284% between a 3- and 4-fold increase in population size between now and 2100. The United States will increase until between 2050 and 2060 and then decrease, and the difference between now and 2100 is a relatively minor increase of 3% in the total population. Indonesia will peak and then decrease to 11% of the current level. Pakistan will peak and decrease and will have an increase from now to 2100 of 16%. You see a decrease in Brazil, a large decrease in Bangladesh of the same magnitude that we will see in China. DR Congo and other sub-Saharan Africa countries will have large population increases, and also Ethiopia, but not as large as DR Congo or Nigeria. Our forecasts, as other forecasts, foresee major changes in the population pyramid between now and 2100. We will move from a world where there are more young people under 20 than old people above 65 to a world with more people above 65 than under 20. Actually, in 2100, there will be 2.4 billion people 65 years and above, and 1.7 billion less than 20. So a huge increase in number of old people and a decrease to a third less than 20. Here I'm showing old age dependency ratio. Number of people 65 years and above per 100 in the working age, which here is set to 20 to 64 years. And I show the curve from 1950 to 2100 for the world in red, for Colombia, Spain, and Japan. And in 1950, this level was about 10 old people, around 10. And in 2100, it's actually around 80 for Colombia, Spain, and Japan, and around 50 for the world. Our numbers here are somewhat higher than those of the medium variant of the United Nations, because our fertility forecasts are generally lower in our reference scenario. This is our reference scenario. This is another visualization of changes in age composition in the world for 1950, 2020, 2064, and 2100. I show the proportion of the population that is younger than 20, shown in green. We see that in 1950, this is about half the population. Whereas there is less than 5% people 65 and over. And actually this situation in sub-Saharan Africa is relatively unchanged from 1950 to today. Still more than 50% under 20 and less than 5% over 65. Whereas the situation in the rest of the world has changed a lot, and the proportion of young people is around 30%, and old people is about 10%. And then if we jump to 2100, we see that the proportion of young people under 20 is not varying that much. Even in sub-Saharan Africa, it's just above 20, and above 15 in Asia, and around 20 in the rest of the world and the world total. Whereas the population 65 plus is around 30% in the world outside of sub-Saharan Africa, and about 20% in sub-Saharan Africa. We also estimated working age populations. So, and here we see that the dramatic increase in working age population in sub-Saharan Africa, that is increasing throughout the century to about 2090, and then staying relatively stable at a high level of 1.8 billion. We see increases in South Asia driven by India until 2050, and then a decrease. The decrease in Southeast Asia, East Asia, and Oceania, driven to a large extent by China, is going to start around 2030 and then decrease relatively linearly all the way until 2100. We see at high income countries, working age population is declining. In North Africa and Middle East, it will increase until 2070 and then stay relatively stable with a small decline. In Latin America and Caribbean, we will see a slight increase in working age population until around 2050, and then a decrease. And in Central East Europe, Eastern Europe, and Central Asia, working age populations will decrease from now and to the end of the century. Since IHME also produces estimates of GDP dollar per worker, we have constructed this ranking of total top world economies from 2017 to 2100 just by multiplying the previous estimates of working age population with our estimates of GDP dollar produced per worker. What we see here is that the countries, say in the top 10 economies, do not change that much. China will become the major economy between 2030 and 2050, but will be surpassed by the United States again towards the end of the century. India will move up. Nigeria will move up, and the European countries that also are in the top 10 will stay relatively high. We see that, for example, Mexico will stay relatively stable around a ranking of 15. This is a comparison of the global population according to IHME, United Nations Population Division, and the Wittgenstein Center. Here we see that the Wittgenstein Center have forecasts that are not too different from those we produce. The Wittgenstein Center see a peak a bit later than us, around 2070, and then a decrease in population to 9.3 billion, half a billion above our estimate. Whereas the United Nations see a continued population increase until 2100, where the population is estimated in the medium variant to be 10.9 billion, 2 billion above our estimate. But we also see that there is a slowdown in the growth of the world population towards the end of the century. Here I show on the left-hand side the global estimates, and this is a comparison between the United Nations estimates in light blue and the IHME estimates in green. And we see that our forecasts are very similar for the next generation. For the next 30 years until 2050, we can hardly see differences between our estimates and those of the United Nations. There is some decline in our estimates compared to United Nations in China and India, so we can see a slight difference there. But the major differences, they happen between 2050 and 2100. We also see that we agree on the growth in Africa from 2020 to 2050. And our estimate of the sub-Saharan Africa population in 2050 is almost exactly the same. The difference in our estimates for sub-Saharan Africa, they happen towards the end of the century, where actually the United Nations is projecting almost 1 billion more growth in sub-Saharan Africa than we do. And we have larger declines in Asian populations, and some more decline in high-income countries. And then, for example, Latin America and Caribbean estimates are very similar as a total from the United Nations or our estimates. This is another representation of the difference between the estimates of the United Nations in light blue and ours in green. This is the difference in population between 2017 and 2100. We see that for high income and for Central Europe, Eastern Europe and Central Asia, differences are relatively small. We both see a growth in North Africa and Middle East. We took close to 400 million and the United Nations 100 million more. For South Asia, United Nations see a growth, whereas we see a decrease of about 300 billion in opposite directions, driven by differences in our forecast for India. And then Southeast Asia, East Asia, and Oceania, we project a much larger decline than the United Nations. And as mentioned before, the United Nations see a larger increase in sub-Saharan Africa than we forecast in our reference projection in the future. I think I will skip this graph. This shows that when it comes to the number of countries below 2.1, below replacement in 2100, we agree with the United Nations that it's about 90% of the countries. We are slightly above. When it comes to the number of declining populations, our estimate is a bit higher than the United Nations, but we see very similar, actually, pattern in these parameters. So, to summary, in our reference forecast, the global population will increase by 2 billion, then decline by 1 billion to 8.8 in 2100. The picture for the world is very mixed in that we still have a population explosion in sub-Saharan Africa with an increase from 1 to 3, and if we believe the United Nations projection, it will be 1 to 3, almost 3.8 billion. We see a decline in Asian populations, whereas the United Nations see relatively stable population in Asia. The 5 largest countries in 2100 will be India, Nigeria, China, United States, and Pakistan. Most countries will be below replacement. 23 countries will have population declines of more than 50%. There will be large shifts in age structures to a world with a majority of more people above 65 than below 20. China will be the largest economy in 2035, but will be surpassed by US in 2098 because of the large drop in working age population in China. But our wide uncertainty and differences between scenarios show that what will really determine our future is the world's and countries and the international community's response to the changes that are starting now and already have started in some countries. So there is ample room for policy and other types of and individual responses. I think the key thing, for example, is to prepare for the situation in sub-Saharan Africa, where investments to create workplaces and also investments in education is needed to build the infrastructure necessary to uphold the population growth we are seeing. Thank you.